Dear Professor, I'm very honored to here to make my presentation. So I will introduce my paper, which is called Synchronization for Chaos System by LSSVM Method. I'm Li Nan from North University, and my teacher is Professor Ma. And my research direction is nonlinear stochastic dynamics. So I will introduce these 8 parts. The first one is background, and second one is abstract, and third one is model building, and next one is unbiased LSSVM. And after I will introduce parameter optimization, and after overall steps of the algorithm, and after I will show the numeral stimulation, and finally I will show the conclusion. So let's from the first part, background. Background, as you can see, study have showed that chaotic systems are beneficial to human, and sometimes it's very harmful to human society. Therefore, it is very necessary to control the chaotic behavior. It's very essential to find the new method of chaos. And after is abstract. My paper has three steps. The first one is this one. The hybrid synchronization trajectory and control input signal are obtained under the unbiased LSSVM method. And secondly, I will introduce the parameter optimization. And finally, I will show the master-slave system is achieved. And now let's see the model building. Consider the following nonlinear chaotic system. The first one is the master system, and this one is slave system, and UTXY is the control input. So we will define this control input to figure out this synchronization problem. We can get the error is E equal to X to this one. And we can obtain this equation. If Q equal to 1, the synchronization of the master system and the slave system can be realized. So now I will introduce the algorithm, which is called unbiased LSSVM. LSSVM is a least square support vector machine. As you can see, the unbiased LSSVM method is introduce a fixed value parameter on the basis of this algorithm. We can get unbiased LSSVM through the LSSVM this algorithm. Just we add another parameter, which is called lambda. We can get this level system can be expressed through this method is this equation. And similar the fx of system 1 in the system, we can get this equation. So we can use this algorithm to get this constraint problem is to maximize this equation. So we can make xt1 equal to this one and xti equal to this one. Then we can introducing Lagrange multipliers. We can use this for transformation. after, we can get the formula through above formula. So the synchronization trajectory we can obtain as this one, these three equations. But in this algorithm, we have a kernel function. So kernel function, we choose this one. Can be written as this. And we can obtain the kernel function's derivation. So when m and n equal to 1 or 2, so we can get these three equations. After, I will introduce the parameter optimization. Because of in this algorithm, it has few parameters we need to optimize. So I will use this PSO algorithm to figure out this problem. PSO is called particle swarm optimization. In this algorithm, we can use these two equations to optimize parameters. You can see n is the total number of the particles in this group, and rand is random number between 0 and 1, and xi is the current position of the particle, and c1 and c2 usually we can take as 2. And now I will introduce the overall steps of algorithm process. As you can see, first one, we need to determine fitness function, and after we need to initialize the population and save. The next step is fitness function calculation, and after we need to figure out this fitness celebration. And after we need to go into this circle, update rate and individual, and particular fitness calculation, and after it, update individual extreme values. So we have a condition which is called whether the termination conditions are met. If we satisfied with this condition, so we can get into the conclusion. If not satisfied, so we need to go this step and figure out the problem and go into this circle. Okay, after it's my numerous accumulation. In order to modify this algorithm, I choose these two systems. The first one is driving system. I use this system. And the response system, I choose this one. And the initial state is this one. And this system, initial system is here. So now it's my numerous stimulation conclusion. You can see in this blue line, it's the error. And this one is the synchronization control trajectory. The blue line is Y1 and the yellow one is X1. As you can see, it obtains the control and get the synchronization. And in this two picture is Y2 and X2. And also this picture is shown Y3 and Y4. So now it's my conclusion. We're solving the master system as a set of training samples and combining with the slave system, the hybrid synchronization trajectory is obtained under this algorithm framework. So at the same time, The PSO, this algorithm is used to optimize the parameters of the kernel function. And finally, the synchronization error of the main system approaches to 0. So we can get this method is very effective. So now it's my all introduction. Thank you for watching.